Okay guys, so let's continue on seeing some more examples on the concepts which we discussed in the previous lecture. Okay, so let's get started. So let's see the first question, wherein we have to calculate the molar mass of air sample that contains 80 to 80% mole nitrogen and 20% mole of oxygen. So you have to calculate first molar mass of air which contains 80% mole nitrogen and 20% mole of oxygen. Okay, so molar mass would be is defined as mass of sample over moles of sample. Okay, so mass of sample can be calculated with the given information, which is 80 moles into 28 plus 20 moles into 32, which is the atomic or molecular weight of, or rather molar mass, you can say molar mass of nitrogen and oxygen. Okay, and moles of sample is 100. Okay, from this you can calculate the molar mass of air as 28.8 gram per mole. Okay, now let's suppose you have to calculate also calculate the weight percentage of nitrogen in the mixture. Okay, so weight percent of nitrogen in the mixture would be, again you can use the formula which we discussed in the last lecture, or we can also calculate with going from the beginning, that weight percent of nitrogen in the mixture would be weight of nitrogen upon mass of or weight of mixture, or in this case weight of air. Okay, so weight of nitrogen would be defined as molar mass of nitrogen into mole percentage, which is 80 into mole percentage. Let's suppose 100 moles are there in the mixture, into what is the molar mass of nitrogen, N2 would be 28 upon weight of air would be molar mass is 28.8, and molar mass or number of moles of air we are taking 100. Okay, so 100 multiplied by 28.8. okay, so with this we can actually calculate that weight percentage of nitrogen would be 77.7%. okay, now let's discuss another important topic, which is law of chemical combination. Okay, law of chemical combination. Okay, so law of conservation of mass, which was given by Lavoisier, he said that we can't create or destroy mass. Okay, so this is law of conservation of mass. Law of conservation of mass, which says that mass can't be created and can't be destroyed. Okay, so let's actually see a chemical reaction. A general form of chemical reaction would look like A plus B, which are reactants combining together to form a compound C plus D, which are products. Okay, so total mass of reactants is equals to total mass of products. So total mass of reactants equals total mass of products. Okay, and total mass before reaction, or you can say that total mass before the reaction is equals to total mass after the reaction. Okay, and but in case of nuclear reaction, some mass gets converted into energy, so this theory is not applicable here. So we are not talking about nuclear reactions. Okay, it has a completely different story, which we will discuss in the coming lectures on physical chemistry. Okay, and because in nuclear reaction mass may convert itself into energy, so this law is ideally not applicable for nuclear reactions. Okay, next let's see law of definite proportion. Law of definite proportion. So law of definite proportion states that um, so let's actually discuss this via an example. So in CO2 gas, we can say that 1 mole of CO2 equals 44 gram of carbon dioxide, and in this case mass of carbon was 12 gram and mass of oxygen was 32 grams. Okay, so mass percentage of carbon in CO2 would be 12 divided by 44 into 100. Similarly, mass percentage of oxygen would be 12 or rather 32 divided by 44 into 100. Okay, and mass ratio of carbon and oxygen would be mass ratio of carbon to oxygen would be 12 over 32, or you can say it is 3 over 8. So no matter what is the how is the preparation of CO2 done, and also we are not bothered about what is the source of taking the carbon atom and oxygen atom so as to create a carbon dioxide molecule. The overall mass ratio will still be 3:8. If the carbon dioxide molecule is formed, the mass ratio would be fixed. That is why it is called law of definite proportions. Okay, so this brings us to the end of this lecture. In the next lecture we'll be seeing more on law of chemical combinations. Okay, so till then, good luck and goodbye.